I've been here since 2017.
Okay.
In like the middle of it.
Okay.
It's 2021.
Well, yeah. So I wasn't far off.
Yeah.
Yeah. Nice.
All right. So this is our temporary location. It is the Astronomy Research Facility, the ARF, and here we go. So this first space, and again, this is all temporary. We're working right now on the renovation for agricultural engineering building, which we're calling our permanent location. And so this space we've set up to be, lounge, welcome area. Staff will be here. Flowcharts about how to get help in the space, what we have in the space. What is this space? Sewing, clean and light crafts. What else? General project stuff, the kitchenette, cubbies. These cubbies were made by the All Campus Makerspace staff. One of the things that we're really thinking about right now is every visitor to our space basically comes with a laptop and a backpack and sometimes a skateboard. And there are not that many places on campus with cubbies. And so we put them on chairs. So we have a lot of chairs that are just serving as backpack storage, which is not the greatest use of space. So we're trying to be really creative, like where can we put cubbies, how big do cubbies have to be to fit standard objects, etc. We've got restrooms, and then we have a sink area. This is important. We do a lot of stuff where we gotta wash our hands. So I'm gonna see if the lights, this should work. A little loud. A little flickery. Fine. It was just fixed. It seems to be a bigger issue than I know. How to get the lights to stop flickering. Anyway, so we do, you can wash up, etc., more storage, paint, all these kinds of things. These aprons, so one of our goals with the staff is that all the staff should do something new. In other words, that no single person is like, all right, this is your expertise, you're going to just do this. You're just going to do this one thing and you're never going to have to step outside your comfort zone. Student staff, right, they're students, and the experience is supposed to be about a lot of personal growth, and so we wanted everyone to learn how to do a number of basics, and one of those basics was sewing. That every student should learn how to sew, and so some of our students knew, and they were in charge of teaching the students who didn't know how to sew and use a sewing machine, how to, everything from cutting a pattern to running the machine, threading the machine, troubleshooting issues that come up, and designing this apron. So this is, these are duck cloth aprons. Each person customized the colors. This one in particular, David, president of the cosplay club, made this one. It has pleats. It's absolutely gorgeous. And so these are the shop aprons.
Nice. What really kind of sparked your interest in getting involved in the maker movement, and also talking a little bit about what your interpretation from your perspective, what is the maker movement?
Sure. So it really does, like most things, right? For most people, it started when I was a kid. I spent a lot of time making things, but I didn't have a lot of access to tools, so I would just make what I knew how to make or what I had access to. So, there were a very large group of things I'd be interested in, but there were only a very small group of things that I, could independently do, so I did those. And then in college, I studied engineering. I didn't know why. At first I was maybe art, maybe mechanical engineering, and then, to be perfectly fair, there was this kid I liked, and I was like, okay, you're my classmate, you're cool, I'll do what you're doing. Can I follow you around and learn from you? Once I started to learn what electrical engineering, had to offer, still a total beginner, but I had this newfound power. I wanted to explore it. Can I make this? Can I make that? There's always this balancing act, but there still weren't that many resources available. I need to cut a piece of wood in half. I'd still get stuck every single time. So I made things that were small. I always stuck to small things and to certain things. I usually had access through a lab to a soldering iron, but I didn't have one at home. And so it was this game of what can I make with what I have, but it was very limiting, not to mention you're traveling all the time. And there was no makerspace. Once I got access to a laser cutter because I knew a friend from architecture, and he let me in secretly to go access the laser cutter, right? It was very much like that. None of it was above board. It was all you shouldn't do this in your dorm room, and you're doing it anyway. It's not a good idea from a health and safety perspective. Anyway, so when I graduated, I decided to try graduate school, but I quit after about a year and a half. But in graduate school, again, there was the experience of gaining a whole bunch of new skills and wanting to explore them and getting access to new tools. And so as soon as I moved away from there, I moved to Madison, Wisconsin, and I just went and Googled
makerspace. So one of the reasons was I'd kind of been familiar with that concept from Ann Arbor. I was at Michigan. They had a makerspace, and I had visited. I never really had time to sink into it, but I had visited, and I thought the concept was amazing. So when I moved to Madison, Wisconsin, I just Googled makerspace, hackerspace, and I called up Chris Meyer, and I was like, "Are you open? Can I come over?" And he's like, "It's Friday, so we do tours." I had no clue, and they're like, and the last one starts at 7, so come on by. And I was just like, I just like showed up and I was like, "This is what I need. This is what I want." He's like, "You want to like do a trial period?" I'm like, "I'm gonna pay right now. Can I have a desk? Like, this is the best thing ever." And of course it was. Like, I sussed it out that like this was gonna be amazing for me, and then it was. And so I spent a lot of time there. Just like learning from other people, learning new equipment, like everything was like possible, and there was just a lot of stuff to learn. I did not know how to do like half the things I learned so much over that time. And then I also did a bunch of teaching over the summers, middle school and high school, like robotics courses and stuff, and learned a lot from that. And so then when I finally, when my partner and I, we moved away from Madison, Wisconsin, to Amherst, where we weren't sure we were going to move to Amherst, right? I was just like, where are we going to go? Where shall I start my life? It's got to have a makerspace in it. It's got to. And here in Amherst, there isn't really like the size of community that would support a public makerspace, I don't think. And so, but there's a couple ways to make makerspaces the focal point of your life, and one way is to work in makerspaces. And there weren't that many. At the time, Amherst College is still thinking about it, and they were thinking about it, but not that seriously. And UMass was thinking about it, but they were thinking about it more seriously. So I just kind of showed up and said, "Hey, I know a lot about, I spend a lot of time in this community, like I know a lot about makerspaces. I make a ton of different things, and I'm always learning something new." I think, it was weird. I just showed up, and I joined as a temporary professional. I joined in like kind of like that weird edge case where you're like still figuring out how you fit in at the university. And then I worked really, really, really hard for a couple of years. I still am working really hard. But in those first couple of years, because I think no one defined my role. They were like, "You're a temporary professional. You define it." So I defined it. And then they put a title on it.
You can see we have, I'll turn the lights on here, my corner. My corner is situated here, and it doesn't have a wall, which is kind of important because it means that I hear and smell and see what's happening.
Yeah.
And so first it's hearing and smelling, and then if it smells or sounds like something is amiss, I run over and I inspect it. And things happen. People use too much Bondo, and they should be using it outdoors and not indoors, or not using it at all. So I'm always in the space, present, and I don't really see a way to lock myself off or like wall myself off. So this has been a pretty good zone for me to see what's going on. And then as much as possible, I try to train my student staff to have that confidence, the confidence to step up to someone and say, "That is a dangerous way to use an X-Acto knife. Let me show you how."
That's really good, yeah.
Because, it does take some confidence, right, to be able to tell someone that you don't know, "Hey, I'm the authority here, and I think that you're about to hurt yourself, so I'm going to stop you." And it can be something as simple as an X-Acto knife, too. So how to get, just that presence so I can feel confident and potentially even leave the space open with graduate student or undergraduate student supervision for even 5 minutes at a time.
Yeah.
This space is an interesting mix of different uses. The rocket team lives here, so these are all the rocket team's things, the rockets, their tools, etc. The rocket team is a really cool organization on campus. Students who are interested should definitely check out their website. And then we have a general work area, a projector for meetings and lectures, and this is an improvised fume hood, actually. Not a fume hood, a cabinet exhaust. So this clear tarp lets you work underneath, put your hands under it and you can still work. And then when you turn the fan on, you just take some object and provide a little opening so that air can flow in and out. And that way, if you're doing stuff like, let's say you were just outside, you spray painted something, but it's not really done off-gassing, if you put it indoors for the night so it doesn't get rained on, it's going to make the whole building smell. So you just leave it in here with the fan on all night, and then, as it cures, it off-gasses outside. We have the rocket team's flammables cabinet, which is really important. This makes the rocket go, but it also needs to be contained. And here is one of their rockets. I think it's the last, 2 years ago's rocket. So they have new models. We actually, since we're sharing the space with them, this temporary space, we wanted to come up with creative ways to store objects so that we could share it more effectively. And so we actually built them this rocket mount. I think they're pretty happy with it, and we'll build them more rocket mounts the more rockets they build. This is our vacuum former. We've played around with it a little bit, not as much as we wanted to. It's a recent acquisition.
I'm still actually defining that role, right? Like, what can the makerspace do? How many people can it serve? How do we, like, what kind of things, and how do I build the structure up? And right now my big struggle, my big challenge is, let's make it be bigger than me. Let's make it sustain itself without me. I'm desperate to try to take this baby and let it walk on its own so I can, for a moment, like if I get sick, just step away from it. Right now it is so new. It's like really a new organization. So, and there's a lot of moving parts. So safety is a big one, right? Safety, let's say, is the big one. That means that, like, right now, I'm holding it, I'm curling this like baby, and I'm like, all right, like, I'm not ready to put it down on the floor and like trust it not to hit its head, but soon. That right.
So in a space like this, because like, you see a very broad range of equipment in different spaces, and therefore a broad range of different like policies and protocols. Like, so when somebody's coming in to use this space, like, do they have to go through any sort of like certification for using any type of the equipment, or like how does that work?
Right. So at the moment, what we've done so far is that all the equipment is used under supervision of somebody from the staff, right? And not any person of staff, because not everyone knows how to use each piece of equipment. And even so, there will be someone who comes in and has a way of using the equipment that we haven't done before, right? Because equipment is not just like the equipment, right? You can run this table saw in a lot of different ways, and some of them are very straightforward, and some of them are not. And so when a student comes in with something, and we're not sure what actually they want to do, right? We take a bunch of steps back. So they'll come in, they'll say, I need to make this particular cut that's quite complicated. And we'll ask, okay, like, what's the whole project? Let's look at the whole thing. Because often people design stuff, without knowing what's possible or how typically things are done. And so what they propose is really work intensive and maybe even likely to fail. But what they actually want is something that solves this particular problem, which can be done in a bunch of ways, and you provide alternatives, and like, that's the one I want, that'll work, right? Now, once we find that alternative, right, or whatever it is, it may require specialty use. Like, we need to really get this set up in a way that we don't typically do things. Like, it's an operation that is a little bit different than just cutting a piece of wood in a straight line. So at that point, if we identify the right tool, we look on YouTube, we try to understand how people typically set up this process, and what's a safe way to do it, and what are the considerations. And if we do feel like there is a safe way and we understand it, we always do that. Firstly, there's a buddy system. Even for myself, I'm not going to work in here alone on the power tools. And secondly, doing a lot of research ahead of time, watching people make that cut. Because there's no way to say, like, all right, like, after an hour, 3 hour, 10 hours of training, you know this machine in and out, you can do every single thing. You can still accidentally fling a piece of wood at your head and give yourself a concussion if you don't know what you're doing. And so we're trying to think about, like, the physics of it really, really carefully.
So I guess the two tools that you use in the shop most often would be the miter saw. It's got a compound sliding miter. It's got all these different degrees of freedom. This part, that part. I use this a lot, and then the table saw. You can get a lot done with just those two tools. And then we also have our stock material storage, our bandsaw, and our drill press. Our drill press was in the middle of a belt change the day before the pandemic started.
Oh my gosh.
So I need to talk to this person who has since graduated and ask them how to finish this up. It was like going to be, it's dripping some oil. It was going to be done. It was just that it was a little bit tricky to get the belt back on. So, we'll get it back on. It was actually donated from the radio astronomy machine shop. They had more than they could use. They have like so many drill presses and only like a couple people working there.
Nice.
So they were like, and we used it a lot. So I just got to get it running again. And then this is the bandsaw, and this is our stock material storage, which I need to redo actually. What we're going to do is put benches in here and have the stock material storage. We're going to cut the stock material down to like 4 foot by 4 foot sections probably. It's a bit more manageable for a space of this size, and stash it in a much more compact manner.
Nice.
And then we have, so all the 3D printers, I moved them in to another location right now, M5, so that I could just print in one location instead of running back and forth. This is a very large hammer from, we did a float on the parade along with the cosplay club. It was like a UMass Makerspace cosplay club collaboration, and we made all kinds of cool props for that.
And yeah, so the 3D printers normally live like right up here, but during the pandemic, at some point, I was printing so many things for students who couldn't come to campus, who were enrolled in courses, that I moved them all into one location, and I put 2 of them in my house so I could run them overnight.
Yeah.
So I was doing like 3 weeks, 24-hour continuous running of machines. I would wake up in the morning, first thing, I would just flip the printer, take the spatula, move the part off, not spatula, the paint knife, and then start the next one. But they're going to come back soon. And then we have, these are all salvage. So these are universal power supplies, with batteries, lead acid batteries in them. And so they run the printers in case there's a power outage. We keep running the printers. And we actually just got them from someone was throwing them away on campus. We replaced the batteries and they're good to go again. The batteries, obviously, they have a lifetime. What else? This is the Minecraft server cabinet. At some point, some students had a project to actually run a Minecraft server out of this cabinet. Now, to be perfectly fair, is it cost effective? No, not really, right? It was more of a learning project. What you should really do if you want Minecraft is pay for, but if you want the experience of doing this, then you should do this because it's so much fun.
Yeah.
I don't think we're going to run that again, but we do a lot of stuff with computers, computer recycling, computer building. There's some students who are interested in that. And so what I want to do is connect students with other students, because I know there's some students on campus. I've met them. Some students on campus can fix your computer, really fix it, even if it's dead. They know what to fix. They know how to look under a microscope. They know how to identify individual components. They watch Louis Rossmann on YouTube. They get it. And other students, they have interest in learning. So if we can put that group together, some goodies. We have iFixit kits. We have some really nice stainless steel ones. You can take anything apart and then find a community and put it back together again, hopefully working this time.
Cool.
Things like depths of cut, exposed blade, catching hazards, pinching hazards, large sheet material has a tendency to bounce up and down, stuff like that.
I know. Yeah, I think about that a lot with using handheld saws like a chainsaw and the kickback.
Yeah.
Because you never know, depending on the composite you're working with, the material you're cutting through,
or the angle you have it.
Anything, can just.
Right, the kickback is a huge issue, right? And it can be. That's where you can really or really tiny pieces or really, really big pieces. Whenever we stretch the envelope of what the machine is designed to do, an 8-foot sheet on this thing, it's a big sheet. It requires 2 people to handle. And especially if it has a tendency to oscillate or whatever, Yeah,
no, there's a lot to think about.
So, it's not about the reliability. There's that, there's the waivers, but there's not just all right, you took an hour-long session, you're trained. It's not really how that works, right? It's a lifetime of experience, and
Yeah, a lifetime of experience you're trying to pack into something digestible that can prevent you at least from losing a part of your body so significant that you couldn't engage in that activity again.
Right, and so when I think about these tools, my level of, comfort with leaving people alone with them depends on what I think the hazards are. And so for me, one of my biggest fears is that somebody will do something with a precariously positioned ladder, because that's it's I think people are often overconfident on ladders, and they can really hurt themselves. But generally speaking, the scroll saw, you might cut your finger somewhat. It's not the same. Whereas that CNC, that mill lathe combo, I do worry about that one. Because I don't know where, it's like driving a car. A small slip up can lead to a very impactful impact, and so I try to think about that. So how I spend my time supervising other people, because I do not want to sit there and helicopter over someone. And that's part of the reason why I'm always driving people towards prototyping with easier to use materials and quicker and more independently. Because I think a lot of us really get stuck I'm going to need this thing out of titanium, water jet. No, you don't. That's very expensive, and access to the water jet is very restrictive, and you're going to really be upset when you cut it wrong the first time. We always cut it wrong the first time, right? Measure once, cut cut a million times. And you're going to be upset when you wasted that sheet of titanium. So cut it out of cardboard first. Look at it. You learn a lot just from doing that. And once people get independent, they work faster. They suddenly feel empowered. They do more iterations. They see. And it's much better than waiting for other people, right? You're always waiting for access to something, waiting for training. That sucks.
Yeah.
And this is the largest room in the space. So it's the wood shop / general purpose shop, mostly wood. We don't really have metalworking here right now in this particular location, but it is in the plans for the renovation of agricultural engineering. And we will actually be, we expect to share this space with a number of other student organizations, and it makes sense. It's a really good partnership because we provide a lot of tools and know-how, and they do as well. And so it's really just like, it becomes actually built in a makerspace community, right? Because these organizations are very makerspace adjacent anyway. So one of those groups, the Formula SAE team, the robotics team, which I've spoken with already a lot about their plans. The SMV, the super mileage vehicle team, they actually have this space beyond that door. And I'm going to actually email someone. I hear a hissing, and I think it's just fine. I'm sure that it's something that someone knows about and is supposed to be running. But just in case it's like water that's doing something weird, I ask them. So this space, we've got the table says it's a 5 horsepower sauce stop with all the accessories. It really has been useful. So the point where like there are other places on campus where I have access to a saw stop table saw, and sometimes we'll like get set up there, and then it'll be like a little too small, a little difficult to work with, or whatever. I'll be like, let's just go here. Let's just do it here because it's easier. And it's on wheels too, so we can move it around as we need to. We have a scroll saw. I love the scroll saw. Scroll saw is a great way to get into woodworking. If a lot of students they don't have the budget to do furniture, like fine furniture making, or the space. You're building huge things like beds if you're doing furniture making, or couches. So if you want to get started with something a bit smaller and more friendly too, you can do all kinds of really cool stuff. I forget how you pronounce it, but marquetry, where we take shapes, cut them. You glue them together. They fit, interlock nicely. You can have inlay essentially. Anyway, so the scroll saw is really fun. It's not a scary tool. It's I'm not gonna say that none of the shop tools. Some of them are actually quite scary, and they require kind of a respect and a depth of learning and before you do anything new or interesting. But this one, you can feel a little bit more free to experiment with. Whereas there's some tools where I don't want anything called experimentation. I want only careful research and then followed by approved use cases, right? And usually to me, it's more about like the output torque of the machine. So that puts the CNC in not the CNC, it's a potentially a CNC-able mill lathe concept. It's a combo unit, but the machine that runs the computer numerical control is like from 1990 something, and we have to overhaul that. So for now, it's a manual machine, but I'll show you that one. This is the one where, just careful with this edge. Here, or you can meet me on the other side of this. This is the machine where I don't let people use it without me like watching like a hawk.
Right.
And the reason is simply like this part that turns. If it grabbed you, it wouldn't know, and it wouldn't stop. And it's very powerful. So I think there's something about like a healthy fear. A healthy fear involves watching some videos of people who did lose more than an arm, and understanding what it is it can do. Not with this exact machine, but similar. Let's say I'm not interested to find out. So it's one of those things where a small mistake can be costly, and so we're very, very careful with that. All right, today is Wednesday, June the 16th, 2021. An historic moment. One of the first times I've been in here without a mask on.
Whoa! That's amazing.
It's post-pandemic.
Yeah.